So a lot of you have come, so let's start. So let's start. We have already started with some good level numericals. We have done derivatives in the last class. Limits and continuity is remaining. So that is what we are going to do today. So let's see this limit of x tends to pi by 2 cos of x minus cos of x upon pi minus 2x the whole cube is equal to option number A 1 by 24, option number B 1 by 16, option number C 1 by 8, and option number D 1 by 4. This has come in the year 2017 JEE main. This is come in 2017 main. So let's do it. So if you remember the limits, the formula for the limits are okay. Most of the cases for trigonometric functions, it is limit of x tends to 0. Okay, and here I have limit of x tends to pi by 2. So the moment I see something like this, I will always go for substitution and try to convert it into the limit tends to 0. So whatever is there, that particular thing itself, I'll take it as something else so that I can get 0. So I'll put x minus pi by 2 is equal to t. If I'm doing a substitution, okay, put x minus pi by 2 is equal to t. But everywhere in the question I find out x, therefore I will require the value of x. So from here my x will become t plus pi by 2. Now we'll have to find out the limit. So at x tends to pi by 2, what is the limit over here? Pi by 2. So at x tends to pi by 2, my t will be equal to, so the moment I put pi by 2 over here, I'll get pi by 2 minus pi by 2, that is 0. So when my x will tends to pi by 2, my t will tends to 0. So the given question gets converted as L is equal to, that is L stands for the limit t tends to 0. Instead of x, I am substituting t. So this cos of x, instead of x, that will be t plus pi by 2 minus cos of t plus pi by 2 or pi by 2 plus t upon pi minus 2 into x. So x is t plus pi by 2. The whole cube, so I'll write the whole cube. Okay, so let's solve it. For this, I'll get limit of L is equals to limit of t tends to 0. Okay, pi by 2 plus t. So it will go in the second quadrant. In second quadrant, only sine and cosec are positive. This is cot, so this will be minus. And whenever it is pi by 2 plus minus theta, ratio changes to co-ratio. So cot will get converted into tan, so I'll get minus tan of theta. Similarly, here when I do pi by 2 plus theta, I'll go into the second quadrant. In second quadrant, my cos is negative, so minus minus will become plus. So I'll get here, and whenever it is pi by 2 plus minus theta, ratio changes to co-ratio, so this cos will get converted to sin. So it will give me sin upon pi minus, I multiply this 2 inside, so minus 2t minus 2 into pi by 2 the whole cube. So this 2 gets cancelled, so here I will have, okay, plus pi and this minus pi will get cancelled, so I'll get L is equals to limit of t tends to 0 sine of t minus tan of t upon minus t to 2t the whole cube. Okay, till here it's fine. So here I have t cubed, so therefore I will have to think something else. So I get L is equals to tan can be written as sine by cos. Therefore I write limit of t tends to 0, sin of t minus sin of t by cos of t upon this 2 cube will that will become minus 8 into t cube. So I take minus 1 by 8 out of the limit sign, so I get limit of t tends to 0. I'll equalize the denominator, so I'll get cos t into sine of t minus sine of t whole upon cos of t upon t cube. Therefore, I will get L is equal to minus 1 by 8 limit of t tends to 0 cos t into sin t. There also sin t is there, so I will take sin t as common. When I take sin t as common, so what will remain here is cos of t minus 1. And this cos t goes down. One by 8 limit of t tends to 0 sin t into 1 minus cos t upon t cube into cos of t. Therefore, I will get L is equal to 1 by 8 limit of t tends to 0 sin t 1 minus cos t is 2 times sin square t by 2 half angle formula upon this t cube into cos of t. So this sin t by cos t will become tan t. I will separate this and this 2 also I will take outside the limit. So 2 by 8 limit of t tends to 0 sin by cos can be written as tan of t and t cube can be written as t into t square. So 1 t I will give over here. I can give limit of t tends to 0 and this upon t square. So everything is in multiplication only. So t into t square that will be t cube only. So we don't have to worry. Everything is in multiplication. 2 I have taken outside. Constant will always come outside. Limit, integration and derivative and so on. Now we directly have this formula. Tan of x by x is 1 for okay limit x tends to 0. So this will give me 1. So I will get 2 by 8. So that will become 1 by 4 into 1. And over here limit of t tends to 0, here I have sine of t by 2, sine square t by 2, so it can be written as sine of t by 2 the whole square. So whatever term is over there, the same term I need over here. So I will have to multiply and divide by 4. Okay, so that I can write it as t by, this will be t by 2 the whole square. The 2 square is 4. So this 4 I will take outside. So this 4 into 4 that will become 16. So this will become 1 by 16 into limit of t tends to 0. So this will become sine of t by 2 upon t by 2 the whole square. Here also have square, here also have square. This 4 I have taken outside. Okay. So now sine of x by x this is 1. So 1 square that will become 1. So 1 by 16 into 1 that will be 1 by 16. So I get the value of limit as 1 by 16. So what was my option? Option number B is the answer. Okay, I hope you have understood. Please take the screenshot, and if you have not understood any step, please ask me. If you have not understood any step, then please let me know. Take the screenshot. Okay, let's go to the next question. Next question. Limit of x tends to 0, sine of pi cos square x upon x square is equal to option number A, pi by 2, option number B, 1, option number C, minus pi, and option number D, pi. This is come in the year 2014. JEE made. So this is also come in May. So it has come in 2014. So let's try this. We know the formula is sine of x by x. So whatever is the angle, the same angle should be over here. Then only we can apply the formula which we have studied. Therefore, limit of x tends to 0, sine of pi cos square x. The same term should be there over here. Then only we can apply that formula, sine of x by x is 1. So whatever it means, whatever angle is there over here, the same angle should be here. So here I have angle as pi cos square x. So here also I will have to divide and multiply by pi cos square. And this x square is that x square I will write over here. Okay. So now I can apply the limit separately. So limit of x tends to 0, sine of pi cos square x upon pi cos square x into limit of x tends to 0, pi cos square x upon x square. The sine of x by x is 1. So limit of this will become 1. So I'll get L is equal to 1 into pi is constant, it will come outside. The limit of x tends to 0, and this can be written as cos x by x the whole square. Okay, now limit of x tends to 0. Okay, cos of x by x, this is also 1. So I'll get L is equal to 1 into pi into 1 square. 1 square is 1 only, so I'll get limit of L, limit is 5. So which is the option? Option number D is my answer. Okay, this was also simple one. This has come in the year 2014. Take the screenshot of this. I hope everyone is taking the screenshot. Let's go to the next numerical. Next, limit of x tends to 0, 1 minus cos 2x into 3 plus cos x upon x into tan 4x is equal to option number A 4, option number B 3, option number C 2, option number D 1 by 2. This has come in the year 2013. JEE means 2013. Tan 4x raised to 4x. Okay, this tan 4x. So if I substitute x is equal to 0, I am getting 0 over here. If I give this x separately to this, then for this term again I need x. Okay, let's see. L is equals to limit of x tends to 0, 1 minus cos 2x by x. I'm writing it as separately into 3 plus cos x upon tan of 4x. The main important thing in any limit numerical is that you somehow remove the term which is going to give you infinity. Okay, and the infinity is going to come when there is 0 in the denominator. So here if I put 0, this is going to give me infinity because 0 will come in denominator. So first I will have to think about this. So hence what I'm doing is I'm adjusting 4x. So this, when I apply the limit here separately, this will become 1. Okay. So let's do this. So I'll get L is equal to, and here also meantime 1 minus cos 2x. So 1 minus cos 2x is 2 times sin square x. So this will become 2 times sin square x upon this. Limit of x tends to 0. And here I have this 4x which I had that adjustment. So this 4x I can bring over here. So this x into x that will become x square. The same time I can bring limit of x tends to 0, 3 plus cos x upon limit of x tends to 0, tan of 4x by 4x. This 4x I wrote over here. Okay. So this 2 by 4, this is constant, it will go outside. So this will become limit of x tends to 0, sin of x by x, this whole square. Similarly here, if I apply the limit over here, so I'm not going to get infinity, so I'll not worry, I'll directly apply the limit, so this will become 3 plus cos of 0. And here, tan of x by x is 1, so this limit is giving me the value 1. Similarly, here L is equals to 2 by 2, so that is 1 by 2. Limit of this sin of x by x is 1, so this is 1 square into cos 0 is 1, so this becomes 3 plus 1. Anything upon 1 is the same number, so this is 3 plus 1. So 1 by 2 into 1 into 3 plus 1, that is 4. 2 1s are 2 2s are. So I'm getting limit of it equals to 2. Okay, so which is my option? My answer is option number C. The limit of this is 2. Okay, we don't need to every time just go on solving and simplifying or cancelling anything. The moment you are out of the danger, the moment you are removing 0 from the denominator, you are out of the danger and directly apply the limit. Okay, take the screenshot of this. Take the screenshot. I hope has taken the screenshot. Let's go for the next question. Next question is limit of, it is x tends to infinity, limit of x tends to infinity, x square plus x plus 1 upon x plus 1 minus ax minus b is equals to 4. Then option A is equal to 1, B is equal to 4. Option B, A is equal to 1, B is equal to minus 4. Option C, A is equal to 4, B is equal to minus 3. And option D, A is equal to 2 and B is equal to 3. This is come in the year GMT 2012. So here it is x tends to infinity. So if I substitute everything and get infinity, how to solve infinity numerically? So the basic thing which should be in your mind is this concept. 1 by infinity is 0. So every time will be in the pulses, whenever you get any numerical where the limit is given as x tends to infinity, you'll always try to take x common, cancel out x, and always get the term 1 upon x, 1 upon x square, or 1 upon x cube, whatever it is, always those terms. Why? Because 1 by infinity is 0. So the technique will always be somehow we take the terms common, okay, and get this kind of term 1 upon x, 1 upon x, so that I can substitute the limit and I can. So before that, first we'll equalize the denominator because we need to find out the value of a and b. First let us equalize the denominator from the x square plus x plus 1 minus of x plus 1 into ax plus b, the whole upon x plus 1. I'll get L is equal to limit of x tends to infinity, x square plus x plus 1 minus ax square minus bx minus ax minus b, the whole upon x plus 1. So let L is equal to limit of x tends to infinity. Here from here I take x square common, so what will remain here is 1 minus a. Then from here I take x is common, so here what will remain is 1 and here what will remain is minus b minus a. Okay, then these are the constant term, that is plus 1 minus b, the whole upon x plus 1. Now the entire idea of solving is taking x common and getting the terms 1 upon x, 1 upon x. Now here I have only 1x, so I can take only 1x is common, nothing else. So if I go in denominator, I can take only x is common, so 1 upon 1 by x. There is no x square term in denominator, so Am I audible? Am I audible? Clear? Board is clear, right? Okay. Yes, so I was saying that if this x square term remains, if this x square term remains, then we'll not be able to find out the finite limit. I'll always get infinity over there. But he has given us the value of the limit is 4. It means that the limit exists. But if the x square term is there, then we'll never be able to find out the limit. It will always give me indeterminate value. Which, what does it mean? It means that for limit to exist, for limit to exist, I should not have x square term over there. And when I will not get x square term over there, when this becomes 0, then only the x square term will not be there. What does it mean? It means that my 1 minus a should be 0. Only if my term 1 minus a is 0, this x square term will not be there and now the limit will exist. Which means we reach to a very important concept. My degree of numerator should be equal to degree of denominator when I have a numerical of limit x tends to infinity. Whenever I have a numerical where I have, okay, limit x tends to infinity, remember one thing, my degree of the numerator should be equal to degree of the denominator for the limit to exist. If the degree of the numerator is not equal to degree of the denominator, then the limit will not exist. Why? Because we have only one technique or only one way of getting the limit. That is, we know that 1 by infinity is 0. Any numerical which is of limit x tends to infinity can be solved by only one and the one technique. That is 1 by infinity is 0. And for that, the degree of numerator should be equal to degree of denominator. If the degree is greater in denominator or if the degree is greater in numerator, one x will always remain. And that x will always give me, okay, infinity. Okay. So, again coming back to this, the degree of numerator in this case is greater, so only if this x square term is 0, the limit will exist, which means my 1 minus a should be equal to 0, which means if a goes over there, I get a is equal to 1. So, from here, either option A or option B is my answer because I've got my a should be equal to 1. If and only if my a is equal to 1, my limit will exist. So, we consider that limit exists, which means this term is not there. So I'll get limit of x tends to infinity of x into 1 minus b minus a plus 1 minus b, the whole upon x plus 1. So now I will take x as common. So I'll get x is L is equal to limit of x tends to infinity. And taking x as common, so what will remain here is 1 minus b minus a, and what will remain here is plus 1 minus b upon x. The whole upon here also I take x is common, so what will remain here is 1, and what will remain here is 1 by x. So this x and this x gets cancelled, so we'll substitute the limits. I'll get L is equal to 1 minus b minus a upon 1 minus b upon infinity. Here, so 1 plus 1 by infinity. So we know something upon infinity is 0, so this will become 1 minus b minus a plus 0 upon 1 plus 0. So that is I get L is equal to 1 minus b minus a. So I get the value of limit is 1 minus b minus a. But he has given that the value of this, the limit of this question is 4. Okay, but he has given L is equal to 4. Therefore, I'll put 4 is equal to 1 minus b minus a. I want to find out the value of b, so I take swap the value, so I'll get b is equal to 1 minus 4 minus a. So I'll get 1 minus 4 minus a. The value of a is 1. So plus 1 minus 1 gets cancelled. So I'll get b is equal to minus 4. So I've got the value of a as 1. I've got the value of b as minus 4. So option number B is my answer. Okay. Option number B is my answer. A is equal to 1, B is equal to minus 4. Hope everyone has understood the numeracy. Okay, please take the screenshot. This is come in the year 2012. Please take the screenshot of this. Hope everyone has taken the screenshot. Let's go for the next question. Next is limit of h tends to 0 f of 2h plus 2 plus h square minus f of 2 upon f of h minus h square plus 1 minus f of 1. Given that f dash of 2 is equal to 6 and f dash of 1 is equal to 4. Then the value of this limit is option number A does not exist. Option number B equal to minus 3 by 2. Option number C equal to 3 by 2. And option number D equal to 3. Okay. So look at this question very carefully. He has given everything in terms of function. If we go back to limits, we have the formulas and we solve it on the basis of formula. But here, no formula or no function is given. Everything is in terms of f or something. Next, the crazy thing about here is, he has given us the values of derivatives. And in the question, we don't have any derivatives. So how do we solve in such cases? So when we have something like this, whenever we have something in terms of derivative, but here we don't have any kind of derivative, we go for one technique which is called as L Hospital's rule. Okay, something called as L Hospital's rule. So what is that? It means we can separately take derivative. Suppose I have something like this, limit of x tends to a, here I have f of x and here I have g of x. So what is L Hospital's rule is, first I can give limits separately to numerator and denominator, and then I can take out whatever amount of how many times derivatives I can. First I write it as something like this: limit of x tends to a f of x upon limit of x tends to a g of x. And now, the moment I write L'Hospital's rule, so I can take derivative. L'Hospital's rule is nothing but means taking derivative. Whenever we have something numerator upon denominator, okay, there, that is the time I can apply L'Hospital's rule in, L'Hospital's rule, we don't do anything else. Nothing new. What we do is only we apply the derivative. Separate the numerators and separate the denominators. So if I write by L'Hospital's rule, it means the limit L will become limit of x tends to a, and here I write f dash of x. Here limit of x tends to a. Here I write g dash of x. I can take second derivative also. Once again, if I apply L'Hospital's rule, then this will become L is equals to limit of x tends to a f double dash of x upon limit of x tends to a g double dash of x. Means till you can take derivative how many times you want. It's not that you can take derivative only once. You can take n number of times the derivative. Okay, so this technique is called as L'Hospital's rule. Okay, which can be applied when we have numerator upon denominator kind of a thing. Okay, where we have numerator upon denominator kind of thing. And L'Hospital rules means nothing but taking derivative of numerator and denominator. So L'Hospital's rule is nothing but taking derivative of numerator and denominator. So here he has given us in terms of f dash, which means he has given in terms of derivative. It clearly gives us an idea that I have to take derivative over here. So let L is equal to limit of x tends to 0 f of 2h plus 2 plus h square minus f of 2 upon limit of h tends to 0 f of h minus h square plus 1 minus f of 1. So now when I take derivative, so let's take the derivative. So when you take derivative, you will write on applying L'Hospital's rule. I'll get L is equal to limit of h tends to 0. The derivative of this will become f dash of 2h plus 2 plus h square into derivative of 2h will be 2, derivative of 2 will be 0, derivative of h square will be 2h. F of 2 will be a constant value, derivative of a constant is 0, so this is minus 0 upon limit of h tends to 0, derivative of this will be nothing but f dash of h minus h square plus 1 by chain rule. Derivative of h will be 1, derivative of h square will be minus 2h, and derivative of 1 will be 0. Similarly, f of 1 will be a constant and derivative of a constant is 0. Okay, so now I will apply the limit also. So let's apply the limit. So on applying the limit, I will get f dash of 2 into 0 plus 2 plus 0 square. And this 2 into 2 plus 2 into 0. Whole upon I am applying the limit. So this will become f dash of 0 minus 0 square plus 1 into 1 minus 2 into 0 plus 1. So I will get 2 into 0 is 0. So this will become f dash of 0 plus 2 plus 0. So that will be 2 into 2 plus 2 into 0. So that will be 2 plus 0. The whole upon 0 minus 0 is 0. 0 plus 1 is 1. So this will be f dash of 1 into 1 minus 2 into 0, so that will be 0. Okay, so I'll get L is equals to f dash of 2 into 2 upon f dash of 1 into 1. So f dash of 2 is how much? 6 into 2 divided by f dash of 1 is how much? 4, and this 1. So that becomes 2 ones are, 2 twos are, 2 ones are, 2 threes are. So that is 3. So I get the value of limit as 3. Okay, so which is the option? Option number D is my answer. Okay, I hope everyone has understood what is L Hospital's rule. It is nothing but simply taking derivative, nothing else. Okay, nothing hi-fi concept. L Hospital's rule means applying derivative and in numerator and denominator simultaneously. And after applying the derivative, you can apply the limit. So whatever numericals you have done up till now can also be done by L Hospital's rule. Okay, whatever numericals you have done in the entire chapter today and in the previous classes also can be done by L Hospital's rule. Okay, take this screenshot first. Taken the screenshot. I hope everyone has taken the screenshot. Let's go to next numerical. Next numerical, limit of x tends to 0, a minus n into nx minus tan of x the whole into sine of nx upon x square. So the limit of this is option number A 0, option number B n plus 1 upon n, option number C n, and option number D n plus 1 by n. So everyone please give it a try. I will solve it, but at least give it a try. See if you are able to solve this. right? Okay, let's see. I can write let L is equals to limit of x tends to 0. What I'm doing it as a minus n into nx minus tan x upon x into limit of x tends to 0 sine of nx by x. So it is x square, it is a multiplication only, and we know we can separate the we can separate the multiplication. We can separate the limits in multiplications and separate the limits, and x square is separated as x into x. So now I'll give the here x separately. So limit of x tends to 0, a minus n into nx upon x minus limit of x tends to 0, tan of x upon x, the whole into limit of x tends to 0, sine of nx upon nx into n. So sine of x by x is 1. We know that limit of sine of x by x is 1. So here I have nx. So here also I need n. Therefore I have multiplied it and divided it by n. Okay. So here L is equals to limit of x tends to 0. Here this x and x gets cancelled. So I'll get a minus n into n. Okay. And here limit of x by x is limit of tan x by x is 1. So here I get. So this is minus 1 into this limit of sine of x by x is 1. So this will also become 1. So 1 into n. So that is n. So I'll multiply this and I'll multiply this n inside. Limit of a constant is constant. I'll multiply this n inside. So I'll get an minus n square, and this n, when I multiply this, minus 1 the whole into n. So value of a, you don't have the value of a, right? So how will do it? Did you try it? Here also we'll have to go with similar technique which we have gone previously, or is the value given? Sorry, I have written an incomplete question. It is given that limit of this is 0. It is given in the question. It is given in the question limit of this is 0. Okay, so after substituting and simplifying everything, we are over here and the limit is given to 0. So I'll equate it to 0. So the n goes 0 upon anything is 0. So I'll get a n minus n square minus 1 is equal to 0. Okay, so I'll get a n minus n square is equal to 1. So this n I shouldn't have multiplied inside. There is no meaning in multiplying it inside. There is no point in multiplying this inside. I wasn't knowing because I have written incomplete question. This is 0. So I get a minus n into n minus 1 is equal to 0. So I get a minus n into n is equal to 1. So I get a minus n is equal to 1 by n. So I get a is equals to, this goes over there, 1 by n upon n. sorry, 1 by n plus n. So this is the value of a. So which is the option? Option number D is my answer, right? I'm getting this. A is equal to 1 upon n plus n. Hope everyone has understood. Please take the screenshot of this. Hope everyone has taken this screenshot. Before moving ahead, one more thing we'll have to do, that I'm giving you one more formula which I have not given you previously, I guess. Everyone is taking the screenshot? Okay. In many questions, we are going to require which we call it as series expansion. So first, let us write and then we'll go for the numerical. Remember this as formula. Series expansion. So first, series of e raised to x. E raised to x in the series expansion form can be written as 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial plus dash dash dash. Second, natural log, so that is ln log of 1 plus x can be written as x minus x square by 2 plus x cube by 3 minus x raised to 4 by 4 plus dash dash dash. So the same pattern is going to get continued. Third, sin x in the series expansion can be written as x minus x cubed by 3 factorial plus x raised to 5 by 5 factorial minus x raised to 7 by 7 factorial plus dash dash dash. So the same pattern will continue. Okay, odd powers and divided by the same factorial. And fourth, cos x expansion, series expansion can be written as 1 minus x square by 2 factorial plus x raised to 4 by 4 factorial minus x raised to 6 by 6 factorial plus dash dash dash. Okay. Next is for tan x. So series expansion of tan x can be written as x plus x cubed by 3 plus 2x raised to 5 by 15 plus dash dash dash. So these are some of the series expansions. Take the screenshot of this. You will have to by heart this, because in many questions will be required to write the series expansion, because without it you will not be able to solve it. Proof of this is available, but not at this level. When you go in engineering, you will have partial derivatives. In partial derivatives, you will have two theorems as Taylor series and Maclaurin series expansion. So you will have a formula or a direct formula of Taylor series and Maclaurin series, which will be in the partial derivative term. And when you substitute the values, when you take any, do find out the Taylor series expansion of e raised to x or Taylor series expansion of ln of 1 by x. So when you apply the formula, at that time you will get this series, entire series, which we call it as Taylor series expansion and Maclaurin series expansion, which comes as application of partial derivatives. So you don't have any partial derivatives in your lower standards, so you don't have proofs for this in lower classes. But when you do your engineering, you will directly derive this over there. Okay, by applying Taylor series and Maclaurin series. I hope everyone has taken the screenshot. In the very next numerical, we are going to use this. So let's go for the next numerical where we are going to use this. So let's see the next question. The integer n for which the integer n for which limit of x tends to 0 cos x minus 1 into cos x minus e raised to x upon x raised to n is a finite non-zero number. Is a finite non-zero number is the value of n for which this limit will give me a finite value is option number A, 2, option number B, minus 2, option number C, option number C, 1 by 2, and option number D, sorry, option number A is 2, option number B is minus 2, option number C is 3, and option number D is 4. So for which value of n? Okay, 2 minus 2, 3 or 4. What should be the value of n for which the given limit gives me the finite value? If I write this question, L is equal to limit of x tends to 0 cos of x minus 1 cos of x minus e raised to x upon x raised to n. If you see over here, you have the term x raised to n and the limit is x tends to 0. Now you don't have any x raised to n term in your numerator. So never in the numerator you will be able to make, or you will be able to take x raised to n and cancel x raised to n. Whatever kind of simplification you do, you are not going to get any x raised to term in the numerator which you can cancel out with denominator. So it will always remain indeterminate. So that is the time when we'll take the help of the series, because we saw, okay, we can write the infinite terms over there in the series. So now we'll take the help of the series so we can get infinite terms over, so that we can get x raised to n term. Okay, we'll get x raised to n term only if I am writing infinite series. Okay, so before that, cos x minus 1, so it can be written as L is equal to limit of x tends to 0 minus sign I will take 1 minus cos x into cos x minus e raised to x upon x raised to n. 1 minus cos x is 2 times sin square x by 2. So we'll get L is equals to limit of x tends to 0 minus 2 times sin square x by 2 upon, so here I can write x square, so this will become x raised to n minus 2 upon cos x minus e raised to x. So I'll take minus 2 outside, limit of x tends to 0, sine of x by 2, the whole square. So here also I should get x by 2. So x by 2 and by 2, the whole square. And this will become limit of x tends to 0, cos of x minus e raised to x upon x raised to n minus 2. Because I've written here x square, so this x raised to n I've written it as x raised to n minus 2. So I have an existing 2. So when it comes from square out, outside the square, it will become 4. So this L will become minus 2 by 4. Limit of x tends to 0, sine of x by 2 upon x by 2, the whole square. So this will become 1. And here then I will write series expansion limit of x tends to 0, cos x minus e raised to x upon x raised to n minus 2. So this 1 square is 1. So minus 2 by 4, that will give me minus 1 by 2. And here now I can write limit of x tends to 0. I can write series of cos x. So what was the series of cos x? It was 1 plus x square by 2 factorial right. This was the expansion, plus minus sign is there. So it is 1 minus, then it is plus. So it is 1 minus x square by 2 plus x raised to 4 by 4 factorial minus 1 minus e raised to x. The e raised to x series was, what was e raised to x series? 1 minus x square by 2 factorial, plus x cubed by 3 factorial plus x raised to 4 by 4 factorial and so on. This was the series of e raised to x, the whole upon x raised to n minus 2. And this 1 by 2 is there only. That is equal to 1 by 2 limit of x tends to 0. So now when I open the bracket, this plus 1 and this minus 1 will get cancelled. Okay, when I open this bracket, this plus 1, this minus 1 will get cancelled. Here I have minus x square by 2 factorial plus x raised to 4 by 4 factorial minus x raised to 6 by 6 factorial plus that. And here minus plus, that will give me minus x square by 2 factorial minus x cubed by 3 factorial minus x raised to 4 by 4 factorial that. It is infinite series, it will continue upon x raised to n minus 2. Okay. So now x square term is not getting cancelled out. X cube term, x raised to 4 term is getting cancelled out. This x raised to 4 term is getting cancelled out. Similarly, x raised to 6 term will also get cancelled out. So I'll get L is equal to minus 1 by 2 limit of x tends to 0. Here I am having 2 x square by 2 factorial minus x cubed by 3 factorial minus x cube by 6 factorial dash 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 upon x raised to n minus 2. Okay, I hope clear. At least you must have got clarity at least here. Now, here I take x square as common, so I'll get L is equals to minus 1 by 2, limit of x tends to 0. I'm taking x square as common, so I'll get minus 2 by 2 factorial. Here minus x by 3 factorial. Here minus x raised to 4 by 6 factorial. Minus dash dash dash. The whole upon x raised to n minus 2. Okay. So now if I want to cancel this x square, so I get minus 1 by 2, limit of x tends to 0. If I want to cancel this x square, so this will be, or if I write, so this will be x square, and here minus 2 factorial is 2 into 1. So this will become 1, minus x by 3 factorial minus x raised to 4 by 6 factorial minus dash dash dash. So this I can write it as x raised to n into x raised to minus 2. So further I will have to take 2 from there. So x raised to 2. So this will further become x raised to minus 2. Now the x square and x square gets cancelled. So I get L is equal to minus 1 by 2, limit of x tends to 0, 1 minus x by 3 factorial minus x raised to 4 by 6 factorial dash 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 upon x raised to n minus 4. Till here it's clear. Hope till here it's clear, x raised to n minus 4. Now when will be the limit exist? Now if I put limit x is equal to 0, I get 1. Now this entire term will get 0, so I don't have any problem. 1 minus 0 is 1. But here, in the denominator, okay, still I have 0. So when I will get the, okay, determinate limit only when it is x raised to 0, because anything raised to 0 is 1. So if I want this limit to give me some finite value, if I want this limit to give some finite value, then this should be x raised to 0, which means my n minus 4 should be equal to 0. Okay. So for L to be finite, this it should be x raised to 0, which means my n minus 4 should be equal to 0, which implies n should be equal to 2. Okay, so my answer is n should be equal to 2. The question is asking the integer n for which this gives me a finite, okay, non-zero solution, finite solution is that what the value of n should be equal to. Okay, I hope you have understood. Take the screenshot. Done. Hope everyone has taken the screenshot. Let's go to the next question. So I hope you have understood where the series expansion can be used. Okay, when I have something like this x raised to n, that is the time when we will have to use the series expansion method. Otherwise, we'll carry on with our normal formula sin x by x is 1. Next question, limit of x tends to 0, x tan x minus 2x tan x upon 1 minus cos 2x the whole square is option number A 2, option number B minus 2, option number C 1 by 2, option number D minus 1 by 2. Okay, so let's do it. We have to solve this limit. L is equals to limit of x tends to 0, x tan x minus 2x tan x upon 1 minus cos 2x is 2 times sin square x, the whole square. So 2 square is 4, 4 will take outside the limit, so L is equals to 1 by 4, limit of x tends to 0, x tan x. So x also can be taken common, right? X tan x minus 2x tan x, the whole upon this 4 I've taken outside, so sine raised to 4x. So what I'm going to do is I'm going to write x raised to 4 over here, x raised to 4. So that I'll get again sin x by x. So I'm adjusting it. So I can write L is equals to 1 by 4, limit of x tends to 0. So from here and here also I take x as common. So what will remain is tan x minus 2 tan of x. So tan to x, just let me, yes, again I made a mistake in writing a question. 2x, 2x, this is 2x, this is tan 2x upon, here I can separate the limit, limit of x tends to 0, sine of x upon x raised to 4 upon x the whole raised to 4. And this limit of x tends to 0, x raised to 4. So this becomes 1, so I'll get L is equals to 1 by 4. Okay. Limit of x tends to 0, 1x gets cancelled. So, and tan 2x, tan 2x formula is, yes, tan 2x can be written as 2 tan x upon 1 minus tan square x minus this 2 tan x the whole upon 1x got cancelled, so what remains here is x cube. Okay, now let me equalize the denominator. So L is equals to 1 by 4, limit of x tends to 0. When I equalize the denominator, so this will become 2 tan x minus 2 tan x into 1 minus tan square x, the whole upon x cube into 1 minus tan square x. So now this 2 tan x and this 2 tan x will get cancelled. So I get L is equal to 1 by 4. This two terms will get cancelled and this minus minus will become plus. that is tan square x upon x cube into 1 minus tan square x. Two tan x got cancelled. Two tan x into 1 minus tan square x is 1 minus tan square x goes below. So this limit of x tends to 0. This further can be written as 1 by 4 limit of x tends to 0 tan square x upon x square into 1 upon x into 1 minus tan square x. So I get L is equal to 1 by 4 when I apply limit over here. Tan of x by x is 1. So this will become 1 into limit of x tends to 0. 1 upon x into 1 minus tan square x. Okay, hope till here it's fine. Have I missed something? Yes, I did mistake. I will have to multiply this term inside, right? So that is 2 tan x into tan x tan cube. Which I have made mistake over here. This is 2 tan cube x. I made a mistake. This 2 will come outside. This is tan cube x, so I don't have to worry about this x. This will come over here. Okay? So I don't have to worry about this x over here. So this will become 1. So 2 upon 4, so that will give me 1 upon 2. And here, now I can apply the limit. So when I apply the limit, I will get 1 by 2, 1 upon 1 minus tan of 0. Tan of 0 is 0, so you don't have to worry. So your L is equal to 1 by 2, 1 upon 1 minus 0. So that is I get L is equal to 1 by 2. So which option? Option number C. So option number C is my answer. Okay, please take the screenshot. I hope everyone has understood. If you have not understood any step, then you can ask me. Taken the screenshot. Okay, then that's it for today. Okay. Have a nice day ahead.
Hello.
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 Meet is being recorded.
How the tortoise you do? Still also come and replay. Bye.
Bye.
Everyone, bye.
Hey, Vaida, we can sit here.
It is recorded. Everyone meeting video welcome bye. So bye.
No one will see video. Yeah.
Bye. Many will see video.
Who
Okay,
will
anyway.
see? Say, இருக்கதே 10 students for maths. That
Yes,
everyone
sometimes
came
teachers
here. Hey, Siddharth was here many times.
Vijay and Naisa is commenting. He's not speaking and he's just commenting in this comment box.
That will also record. In the side it will come.
No.
A channel
Who's, it
don't
depends.
record, but
It depends on either yours or mine will only be in the pop screen.
Yeah. See, message also will record.
Then Okay, everyone watching the video, bye.
Okay, bye. Leaving.